in this problem, we're given a quadratic equation, but with variables thrown in different places, and they want to know what values of k can give us different scenarios. 2 distinct real roots, repeated root, 2 real roots, no real roots. And so what we need to remember is we need to remember how to find the discriminant, and that is the part that goes under the radical, b squared minus 4ac, from from the quadratic formula. And if it is equal to, if it's equal to 0, then that tells us that there is a repeated root. And so that would be here, this part here. If it gives us, if it's greater than 0, then that means that we're going to have something under the radical sign, and that will give us 2 distinct real roots. It also gives us 2 real roots, but 2 real roots could also mean that you could have a repeated root. If this is less than 0, if the discriminant is less than 0, then we'd have no real roots. Let's say this. So B would mean that the discriminant is greater than or equal to 0. And that's the distinction between 2 distinct real roots versus just 2 real roots. 2 real roots could also have one root happening twice. Okay, so now that I've junked this up, let's solve this problem. So we begin by saying that the discriminant equals b squared minus 4ac. B is k plus 3 minus 4. Our a value is k, and our c value is actually, I need to move this, set this equal to 0, so that becomes minus 1 equals 0 if I reword that. Sorry, that's bad notation, but there we go. And so that c value is negative 1. And so I get that the discriminant is k squared plus 6k plus 9 plus 4k, giving me k squared plus 10k plus 9. So once I have that, I want to know, I'm comparing it to 0. I want to know, when is it greater than 0, when is it less than 0, when is it equal to 0. So I'm going to go ahead and factor this, k plus 9 times k plus 1. And the discriminant will equal 0 when k is equal to negative 9 or negative 1. So now, in order to answer all of these questions right here, we need to make a sign diagram. Okay, so we have a sign diagram drawn for us, and the discriminant that we were working with was, we came down to k squared plus 10k plus 9. And so then when I love to start with plugging in 0. So when I plug in 0, the k squared is gone, the 10k is gone, and I have a positive 9, so over here is positive. Since this is already quadratic, I know it's going to be plus minus plus. I could pick other points to put in just to check, but that's the case. Okay, so now we're going to answer for 2 distinct real roots. That means they have to be real. That means the discriminant has to be positive, but they have to be different. Okay, so we can't let the discriminant equal 0. So that, for 2 distinct real roots, we're going to go from negative infinity to negative 9, and then from negative 1 to infinity. Part B says 2 real roots. Well, 2 real roots means that it could possibly have the same root 2 times. And so that goes from negative infinity to negative 9 with a hard bracket. Pick it up again from negative 1 to infinity. And then we have a repeated root. The repeated root would just be, when is it equal to 0? It's that it bounced there at on the x-axis, and that's when k is equal to negative 9 or negative 1. And then part D, I could have gone to another slide, had no real roots, would be in that middle part from negative 9 to negative 1.